Bismillahirrahmanirrahim. I am Laika Deep from Chemistry Department, and the topic of my today's presentation is drying of green chili by using solar dryer. First of all, green chili production and its importance. Green chilies are an important crop worldwide. They are a rich source of nutrients and bioactive compounds like capsicum, which gives them their spicy taste and provides various health benefits. Green chilies are widely used as an ingredient in curries, pickles, chutneys, and other dishes in many cuisines. They are also used as a spice and condiment. The average potential production of green chilies ranges from 3,300 to 5,000 kg per acre in Pakistan. Green chilies have medicinal properties and are used as an anti-cancerous agent, pain reliever, and to prevent heart diseases. They may also help reduce body fat and manage stomach ulcers. However, green chilies should be consumed in moderation as excessive intake can cause side effects like stomach irritation, heartburn, and allergic reactions. It is important to consult with a doctor before using green chilies for medicinal purposes. Why we preserve food? We preserve food to extend its shelf life and prevent it from spoiling. Food preservation methods help maintain the quality, flavor, and nutritional value of the food for a longer period. But by preserving food, we can reduce food waste, save money, and have access to a variety of foods even when they are out of season. There are various methods of food preservation such as canning, freezing, drying, pickling, and fermenting, each suitable for different types of food products. And in this product, we can preserve food by drying methods. The choice of drying method depends on the type of food, desired quality, attributes, and cost considerations. Proper drying techniques help retain the nutritional value, flavor, and aroma and texture of foods while extending their shelf life. Some of the most efficient drying methods for food preservation and reducing losses include: the first method is freeze drying. This method involves freezing the food, then reducing the pressure to allow the frozen water in the food to sublime directly from solid to vapor. Freeze drying preserves the flavor, aroma, texture, and nutritional value of foods very well. This is the basic method how to freeze food by freeze drying. First of all, food is cooled to approximately -40 degrees Fahrenheit or -40 degrees Celsius. Then vacuum is formed around food as temperature slowly rises, and after that the moisture in the food escapes as a gas rather than a liquid. The second method is convection drying. It is also called hot air drying. This method exposes food to a flow of hot air. It is efficient, preserves nutrients, and can dry a wide variety of foods like fruits, vegetables, meat, and fish in a matter of hours. In this construction, we can see how air is entered, and by circling of air around the product and product carrying conveyors, after that it exhaust from the air exhaust from the outlet, and by using this method we can preserve our food for many hours. Next method is spray drying. In this process, the food is atomized into a chamber with hot air, causing the water to evaporate quickly. It is commonly used for drying milk, eggs, juices, and other liquid foods. Here is a schematic diagram of spray drying. First of all, we take a solvent tank. Here we take our solvent, and after that in solution tank we add polymer or any other active reagent. After that we pump it towards the drying chamber. In drying chamber, the temperature is raised, and here at the bottom there is an outlet where the temperature is going towards decreases. After that, there is a collector which collects the products, and at the end you have through the system collectors and system gas blowers, we get our product. The next method is drum drying. Drum dryers use a heated rotating drum to dry fruits like milk, vegetables, juices, and bananas. The heat removes moisture from these liquid or semi-liquid foods. Here we can see there are it is basically contains two drum structures, and from between we pass through the food, and when the food passing between two drums, it is pressed, and by pressing it is converted into the dried products in the form of powder. And next is the basic method, which is a solar dryer, and it is and we concerned about only solar dryer method for drying chilies. As the name implies, sun drying involves drying food products under natural sunny conditions. During the drying process, no energy is consumed. A hot day with a minimum temperature of 35 degrees Celsius and low humidity is ideal for sun drying of foods. Natural drying cannot be used on poor quality produce to achieve good quality dried products. It is estimated that this method limits moisture content to approximately 15%, with sun drying, contamination, and intermittent drying are common problems. Humidity must be low in order for it to be possible. Quinoas, pillars, trays, and other simple equipment are required. A plastic sheet can also be used. There are different types of solar dryers which we use. The working principle of solar dryer is that the principle of a solar dryer is to use solar energy to heat air, which is then circulated through the drying chamber to remove moisture from the food or other materials being dried. The key aspects of how a solar dryer works are: first of all, solar collectors absorb solar radiations and use it to heat air. The heated air has a lower relative humidity, increasing its capacity to absorb moisture. The hot air is then forced or naturally convected through the drying chamber, where it passes over the food or materials, causing the moisture to evaporate. The moist air is then vented out of the system, allowing fresh hot air to continuously circulate through the drying chamber. This closed loop system allows for more controlled and efficient drying compared to open air sun drying, as it prevents contaminations and better regulates temperature and airflow. The size of the solar collectors must be matched to the quantity of food being dried to provide sufficient hot air. Then the construction of a solar dryer. The specific design detail depend on the factors like climate, product being dried, and desired drying capacity. But these core principles help ensure efficient and effective solar drying. The key design principles of a solar dryer are: first of all, solar collectors. The dryer must have an efficient solar collector system to absorb solar radiations and heat the air. This can be a flat plate, parabolic, or other type of solar collector. The size and design of the collectors must match the drying capacity. The second is the drying chamber. The drying chamber should be well insulated and have a transparent cover like glass or UV treated plastic to create a greenhouse effect and trap the heated air. It should have vents at the top and bottom to allow air circulation. Third one is airflow. Proper airflow through the drying chamber is critical. This can be achieved through natural convection or forced air using fans. Airflow should be distributed evenly over the product being dried. Fourth one is product trays. The product should be placed in thin layers on trays made up of materials like plastic mesh to allow good air circulation. And fifth one is heat storage. Incorporating thermal energy storage such as a phase change materials can improve the dryer's performance by providing heat during periods of low solar radiation. And here we can see how a solar radiation works. First of all, through the inlet, there are solar collectors which collect heat from the sun directly, and through the inlet fresh air enters. After that, the inlet and outlet, inlet must be at bottom and outlet must be at top, and they must be at opposite directions. We can see here the inlet present at bottom, and after passing through air all the products, the fans are present at the top which will release the air into the environment. Benefits of a solar dryer and why we use solar dryer other than any method. The main method benefits of using a solar dryer are improved food quality and hygiene compared to sun drying, as the closed systems prevents contamination from dust, rain and pests. Reduced drying time compared to traditional sun drying methods. Significant cost savings by avoiding the need for electricity, gas or fossil fuels to power the drying process. For example, drying 300 kg of fish costs only $9.77 with a solar dryer compared to $404.8 using electric power. Ability to dry in a controlled environment, allowing for better retention of nutrients, color and other quality attributes. Potential to increase incomes for farmers by enabling them to store food for longer periods and sell at higher prices when supply is low. Environmentally friendly, as solar dryers are non-polluting and reduce reliance on fossil fuels. Suitable for use in remote areas lacking access to electricity or other energy sources. In summary, solar dryers provide a cost-effective, hygienic and sustainable way to preserve food while maintaining quality, especially in developing countries with abundant sunshine and limited access to other drying technologies. Economic analysis. The search results provide a comprehensive overview of economic analysis of solar dryers. Solar dryers are an effective and economical way to dry agriculture produce. The way economic analysis for solar dryers include cost analysis, cash flow, payback period and cost benefit analysis. Studies have been found that solar dryers typically have a payback period of less than 4 years and a lifespan of around 20 years. The annualized cost, capital cost and saving over the dryer's lifetime are important matrices to evaluate the economic ability. For example, one study on a solar assisted heat pump dryer found the initial investment was $5 to $21.8 with an annualized cost of $1076.5. The cumulative present worth over 15 years was $28.8 and $27,553.1 for drying tomatoes and carrots, respectively. Payback periods of 3 and 2.6 years. Another study on a greenhouse solar dryer for tomatoes reported favorably economic performance, with the dryer being technically and economically variable for further investment. Overall, the search results indicates that solar dryers can be a cost-effective solution for drying agriculture products with reasonable payback periods and significant lifetime savings compared to traditional drying methods. And if we talk about its application, the search results provide a comprehensive overview of the economic analysis and applications of solar dryers for agriculture products. Solar dryers are a cost-effective and energy-efficient way to dry a variety of agriculture products like crops, fruits, vegetables, and herbs. Studies have found that solar dryers typically have a payback period of less than 4 years and lifespan of around 20 years, making them economically variable. The key economic matrices for evaluating solar dryers include cost analysis, cash flow, payback period, and cost benefit analysis. For example, on study of solar assisted heat pumps dryer found the initial investment was $521.8 with an annualized cost of $1076.5 and a payback period of 3 years of drying tomatoes. Solar dryers have enormous applications across industries such as textile, wood, fruit and food processing, paper, pharmaceutical, and agro industries. They can be used to dry a wide range of agriculture products like raisins, grapes, onions, mangoes, green leafy vegetables, herbs, and many more. Compared to traditional sun drying, solar dryers can dry products 5 times faster, resulting in significant weight reduction and quality preservation. They also protect the product from damage, pests, and unexpected weather conditions. Overall, the search results indicate that solar dryers are a cost-effective and versatile technology with numerous applications in the agriculture and food processing sectors. Thank you.